So now I take that value of 5.3, multiplied with my input signal, which I changed to 50 millivolts. How much does it work out to? 265 millivolts. So what that's saying is on the input side, I've got a little signal like this of 50 millivolts. This is V in. On the output side, it's going to be the same signal, 5 times bigger, and 180 degrees out of phase. So that's V in, this is V out. So what we're going to do in the lab with this circuit is check out over here on a scope my input signal, check out the voltage here for the output signal, and see that it is out of phase and that it is 5 times bigger. Yes, Haley? Yes. Yes, yes, yes. Okay, so I do have 5 minutes. Let me now do the 4 graphs on page 9. So let's do the 4 graphs. Okay. Graph 1 is V in before C in. Okay? Graph 1 is going to be V in before C in. C1 is C in. So, what does graph 1 look like? 0. This is V in. Draw a small signal like this around the 0 with a peak voltage of how much? 50 millivolts. That's graph 1. Graph 2B is V in after C in. And what does the note say for graph B? Superimposed on VB. What is VB? VB is the DC voltage that's present here. So guess what's going to happen to the signal? Here's my signal, maybe music, okay? It's coming in here. As soon as it goes through the C in which is closed, it comes here, it sees a voltage VB. So it's going to ride on top of it. So now I'm going to show a VB first. And what is my VB value? Go back to your calculation on page 7. How much was VB? 1.76. So VB is a DC voltage, and my AC signal, that music signal, if I was to look at it on the scope at this point, it's going to be with a DC offset of 1.76, and there's my signal. Okay, that signal is then going to go through the amplification of 5, and it's now going to appear here before this capacitor and then after the capacitor. So then the third graph is V out before C out. What is the signal before C out? It is at this point. What is this voltage DC? VC. So now what do? Show a VC value here. How much is VC? Tell me. 9.2 volts. So I go 9.2 volts from my 0. This is DC offset, okay? And at that point, my input signal is going to be amplified 5 times and with an offset. So what do I show here? My amplified signal. Obviously, you can see that it is not to scale, but that's what it's going to look like. You see how I drew it 180 degrees out of phase? So this is going to be how much? 265 millivolts. And it's going to be 9.2 volts from 0. Then what happens is, after C out, V out, after C out, okay, the DC signal is blocked by the capacitor. Capacitors will block DC, but it will allow AC to go through. So if the DC is blocked, what happens to my signal? I'm right on the 0, and it's going to be 265 millivolts, and minus 265 millivolts. So that's the signal I drew here, V in and V out, right about the 0. Okay, so this is what we're going to experience in the lab this week for case 1. And then what I'll do is I'll put a load, I'll put a capacitor, and look at the difference between with capacitor, without capacitor, with load, without load, my 4 cases. Excellent. You are the best audience I've ever had.